Welcome to the second part of this series. In this episode, we'll be focusing on sprite animation. As you can see, this knight is going up and down. Also, one extra thing we'll be talking about in this episode is allowing the knight to move based on the key direction. So without wasting time, let's get started. Before we get started, I do want to shout out the asset pack we'll be using. We'll be using the Dungeon Gathering asset pack. This is the pack that we'll be using. It has a bunch of stuff. Of course, I'm using the free version, not the full one. If you want the full one, you should probably support the developer by downloading and paying money. So yeah, this is the asset pack we'll be using. The first thing we want to do is open the project from last time. Next, we're going to add the assets we're going to use for the sprite animation. Click on Do, then Assets. Afterwards, click on the name of the project, then Sprites, and then from Files. Then click on the folder of the file of the assets and select both of the assets and click Open. Now the assets are in the Sprite folder, which we have, and we're going to use for the animation. Before we start, let's go to the main file and let's remove the shape renderer because we won't be using it for this episode. And let's hold this file and then delete it. Before we write the class to animate the knight, let's examine how sprite animation works. Here we have an image of an animation atlas. This particular one is the animation of the knight running. What we want to do is divide the atlas into each frame of the animation. So we're going to make each row equal its own animation. Row 1 is the front animation, row 2 is the right animation, row 3 is the back animation, and row 4 is the left animation. How we make an animation is that we take each row and cycle through each column and change it based on the frame rate. When we cycle through the frames using the frame rate, it makes it look like a nice running animation. Now it's time to write the Sprite Animator class. This is quite a complex class, but I'll do my best to try to explain it. We have 5 functions: the created function, the set sheet function, the add row function, the play function, and the update function. In the created function, we initialize a lot of variables: the FPS, all the animations, which is going to be in a list, the current animation, and the name of the current animation being played. The next variable is the animation sheet image, which is just basically the regular image, and the atlas is basically when we divide the image into its individual grid cells. Next, we keep track of the amount of columns and rows that are in the atlas. Next, we keep track on what frame number we're on. The last time keeps track of the time the image was changed last, and we'll use this with the FPS to change the frame appropriately. And the last variable checks if the animation is playing. The next function we'll focus on is the set sheet function. The first line of code loads the file from the image. The second line of code makes the image not smooth, meaning that it's gonna look pixelated. This is particularly great for the style of pixel art we're using. Now we convert the image into an atlas, and we set the size of the cell to be equal to the size variable from the parameter. For this case, it will be 16 by 17. The next thing we do is calculate the number of columns. We do that by taking the width of the image and divide it by the width of the cell. We do the same for the row, but we use the height instead. We return self because we want to have a chain of a bunch of functions. We do this by returning the actual class itself, which is self. The next function we'll be talking about is the add row function. This function basically adds each individual row and make it its own animation. The first line of code basically adds a new key into the animations, which is going to be the name of the animation we have, and we set this to be an empty list because we want to add all the frames of the animation in it. The for loop basically adds each image in that row from one column to the next column until we reach the end of the row. In the column brackets, we put the C and then the column number and then R and then the row number. For example, C1R1 would basically be the first row and the first column. After adding all the frames of the row, we basically return self so we can continue the chain. The next function we'll be talking about is the play function. This is the function that lets us know what animation we should play. The first thing we do is check if the current animation is not playing. The reason why we do this is so that if it's playing, we don't want to stop it and keep repeating it, which would make it look like it's on frame 1 all the time. We set the animation name and then we get the current animation from the animation list. Set the animation frame to 1 and then we make it stop playing. Finally, we set the last time to be nil. This will be used in the update function. Next function is the update function. This is going to happen every frame. We first make sure that an animation is playing. Next, we check if the last time is nil. This basically happens when we first start playing. We set it to become the current time by using time.elapse. The if statement checks if the difference between the current time and the last time is greater than 1 over the FPS. 1 over the FPS is basically the time offset we have to go, the threshold we have to pass in order to change the frame. Suppose the FPS is 8, we'll basically have to make sure that the difference between the current time and the last time is greater than an eighth of a second. And once the threshold is passed, we basically change the frame number by 1 and we check if the frame number is greater than the number of frames in that animation. If so, we set it to 1 so we can keep looping the animation. Then we change the last time to be the current time so that the next time it will use that last time in the if statement above. Finally, we set the entity sprite. The sprite variable is basically the image that the entity has, and we set that to become the current frame it is using the frame number. So we go to the animation list, which is just a bunch of images, and we get that specific frame from that number we have, the current frame number, and we get the image from there. We've finished writing the class now. Let's go back to the main function. In the main function, we're basically going to add a gap between the physics body and the entity so that we can add the animator. In the time lapse, I set up the animator. Here is the final result. First thing we do is add the animator component and set the FPS to 12. Afterwards, we set the sheet of the animator for the run animation. The size of the sheet is 16 by 17. Then we continue to add every single row, starting from the first row, which is the down run, then the second row, which is the right run, then the third row, which is the up run, then the fourth row, which is the left run. We do the same thing for the idle animation. Just remember that the size is 16 by 16 and not 16 by 17. Also, we changed the name from run to idle to match the state of the animation. Afterwards, we play the run animation. Let's run the code now. As you can see, there's a little knight down there which is moving, but it's very hard to see because it's very small. You can move around still, but it's very small to see the knight. So let's go and change the size of the knight. Let's change some of the properties of the scene. The first one we're going to change the alpha size so we can zoom it in a little bit to 14. Afterwards, we're going to change the pixels per unit to 16. The reason why is the sprite is 16 by 16 wide, so we want to make the unit 16 by 16 wide. Afterwards, we're going to change the color to a more bluish color, and then finally we'll change the movement to 3. Let's run the project now. As you can see, the knight is much bigger and it's moving around very nicely. But one thing I want to add is the ability to change the direction of the knight based on the arrow keys we're pressing. So that's the next thing we're going to work on. We're going to go back to the movement file and change some of the code. First thing I did was add 3 properties to the created function. First property is the facing direction. This is the up, down, left, right direction that the knight is facing. The next property is the movement state, which is either running or idle, which is the 2 states that the knight can be in. We start off by making the facing direction downward and then making the movement state idle. The third property is the animator. The way we get it is by using the entity property of the class to get the sprite component using the get function. Next, we're going to move to the update method. The first thing I did was to change the facing direction based on the key that's being pressed. D for right, A for left, W for up, and S for down. Next thing I did was to change the move state to idle if the velocity is 0 or running if it is not. Finally, I called a function called adjust animation. What I did in the function was to play the correct animation based on the facing direction and the movement state. Okay, let's now run the project. As you can see, the knight faces the direction that it is going. So if I go up, it will go up. If I go right, it goes right. If I go left, it goes left. If it goes down, it goes down. It plays the correct idle animation. And you can do diagonalies and all these stuff will work perfectly fine. That concludes this episode. In the next episode, we'll be talking about Z sorting. So we'll add a coin and allow the knight to go in front of the coin and behind the coin, depending on what position it is. So please subscribe and have a good day.